In this video, we are going to take a look at nmap and port scanning. We are going to have two targets in this video. Our first target is going to be scanme.nmap.org. So this server is available on the internet for everyone. It says that we are authorized to scan this machine. So in this case, the owner of the website gave us explicit permission, and this server has been set up for learning purposes. So feel free to scan it, but do not scan other people's servers unless you have permission to do so or you own the target machine. Obviously, I can't control the firewall of this host, so I choose another target in my own network to demonstrate how the firewall setups affect the scanning results. Our second target is going to be my Raspberry Pi with this IP address in my own subnet. After this short disclaimer, let's start with host discovery. I'm going to run a packet capture with Wireshark alongside this scan to better understand how nmap works. We are going to apply a filter for this IP address. We are going to perform the host discovery with the -SN switch. So we can specify whole subnets like this, or individual hosts like this. So let's find out if this host is up. Nmap sends various probes or packets to the target and waits for response. For example, we have sent an ICMP echo request, or ping in other words, and got a response for that. We have also sent various TCP packets to different ports and an ICMP timestamp request. And we've got answers for our packets. So nmap concluded that our target host is up. We can also specify which packets to use for host discovery. With the -PE switch, we are only sending an ICMP echo request and got a response. We can use the -PP switch for the timestamp method, or the -PS switch for a SYN ping to port 80. So we have determined that the target host is up. Now we want to know which ports are open on the target host. Let's start with TCP Connect Scan. We perform this scan with the -ST switch, and we are going to change our target to my Raspberry Pi. So by default, we are sending TCP SYN packets to the top 1000 ports on the target host. Not the first 1000, but we can specify individual ports with the -P switch. So for example, if I only want to scan the first 100 ports, we can specify that like this. Or if we want to scan all ports, we can do it like this. By the way, this takes a lot of time, so we are not going to run this scan. Let's perform this scan with the top 1000 ports. I have 5 ports open and 995 ports filtered from the 1000 ports which we have scanned. So how does this work and what does filtered mean? So as you can see, there are many SYN packets here which we have sent to the target. We are sending TCP SYNs to each port, and if the port is open, the target sends a SYN ACK back to perform the TCP three-way handshake. So for example, let's see port 22, which is open. Target answers with a SYN ACK, and we send back an ACK to perform the full three-way handshake. And right away, we close this connection with a reset, but based on the SYN ACK of the target, we can determine that this port is open and there is a service listening on this port. Now let's take port 23, which is filtered based on the scanning results. We have sent 3 TCP SYNs and we've got no answer back. So the firewall dropped our packets and nmap can't determine if there is a service listening on this port. So that is what filtered means. Now let's change the firewall configuration of the target host. These are my firewall rules. These are the ports which we have seen before. They are open indeed, and we drop every other packet according to the default policy for the incoming packets. So now I am going to turn off the firewall and perform the same TCP Connect Scan. The same ports are open, no surprise, but the other 995 ports are closed this time, not filtered. So what is the difference? The difference is that the firewall didn't drop our SYN packets, and according to the specification of the TCP protocol, closed ports should respond with a reset if there is no service listening on the port. And that is what we see right here for port 23. The target responded with a TCP reset. So now let's move on to the TCP Stealth Scan. We can perform this scan with the -SS switch. It is very similar to the previous Connect Scan. The difference is that we don't complete the full TCP three-way handshake. So let's see in Wireshark for port 22. After the SYN ACK from the target, we close the connection right away with a reset. And for closed ports, like 23, for example, the rules are the same, so the target responds with a reset. So this scan is less obtrusive, I guess, and IDSs might not detect it, but in real life there is no real practical difference between the two. So to summarize, there is a really good explanation on nmap.org. The target sends back a SYN ACK for open ports and reset for closed ports. And if we get no response or an ICMP unreachable, that means that the firewall dropped our SYN packet and we cannot determine if the port is open or closed. Now let's move on to the fin, NULL, and XMAS scans. I put these in one category because the same rules apply to each of them. The open ports don't respond to these packets, but closed ports should respond with reset. So it's like an inverse TCP scan. We look for no response, and if we get a response back, that indicates that the port is closed. So let's see in practice. We start with the fin scan. Open ports don't respond at all, like port 22, and closed ports respond with reset, like port 23. But because of the missing response, nmap can decide whether these ports are open or filtered. Because also the firewall could have dropped these packets. What if I enable the firewall on the target? Nmap can't say anything for certain, since we have received no response. These ports could be open, but it is also imaginable that the firewall is dropping our packets. So the only thing we can say for sure is that the target is up. So at the beginning of the scan, nmap sends some initial packets for host discovery, like ARP request, echo request, and we've got response for that. So that's all we can say after performing this scan. Let's move on to the NULL scan. I disabled the firewall on the target. It is very similar to the fin scan, except that we don't set any flags in the TCP header. So for closed ports like TCP 23, the target sends back a reset. And for open ports like 22, we get no response at all. Again, if I enable the firewall, I wouldn't get any useful results here because nmap would categorize all ports as open or filtered. The last one is the XMAS scan. And this is a special one because we set up the fin, the push, and the urgent flags in the TCP header. Again, the rules are the same as the previous two scans. So closed ports respond with TCP reset, and open ports should not respond. If the firewall is blocking the port and dropping the packets, we should also get the same result. So open or filtered. If we get an ICMP unreachable from the firewall, we can say that the port is filtered, I guess, but the firewalls usually don't respond with ICMPs. They just drop the packet silently. The next one is the ACK Scan. This is used for detecting firewalls and to differentiate between stateless and stateful firewalls. So we set the ACK flag in the TCP header, and both open and closed ports should respond with reset. And if we get no response, we know that the firewall blocks the given port. So let's see in action if the firewall is enabled, as you can see. Unfiltered means that we got a reset back, like for port 22. This doesn't necessarily mean that there is a service listening on the port. It only means that the firewall is not blocking this port. Take port 23, for example. We didn't get a response, so we can say for sure that the firewall dropped our packet. That's why this port is filtered. Now, what if I turn off the firewall? Yes, you guessed it. Every port is going to be unfiltered. So let's test it. All we can say after the scan that the firewall is not blocking these ports on the target. Now, what if we have a stateful firewall? I'm gonna stop UFW, mask the service, and I'm gonna use IP tables to write some stateful firewall rules. Packets which belong to an already established and existing connection are going to match this first rule, and packets which have the SYN flag set are going to match the other rules according to the port number, and every other packet is going to be discarded without a response, as we have specified using the drop policy. So let's run the same scan again. And we got some interesting results. All port is filtered, so it looks like the firewall is blocking all ports on the target, which is obviously not true. But this time the firewall is stateful, which means it just simply drops our ACK packets. So the ACK scan can be useful to determine whether the firewall is stateful or stateless. UDP works very differently than TCP. Since it's a connectionless protocol, we can't rely on the SYN packets. So the basic rules for UDP scans are the following. Closed ports should respond with an ICMP port unreachable, and open UDP ports won't respond to our probes. Another important thing to note that UDP scans take much more time than TCP scans. We have seen that TCP scan takes a few seconds to complete for 1000 port. A UDP scan for 1000 port takes like 10-15 minutes. So I am not gonna run a full UDP scan in this video, but I have already run a UDP scan against scanme.nmap.org. And if I remember correctly, port 123 was open. So we are going to scan only 2 ports here to speed things up, specifying with the -p switch. We receive an ICMP port unreachable for closed ports, and we might receive a packet as we have here for open ports. So we've got a response from the NTP server, and based on this information we can say for sure that this port is open. But let's take another example. Let's scan for port 68 as well. As we can see, we didn't get a response. So this port is either open, or because of the lack of response, as I have said before, there is a firewall blocking this port. So these are the basic principles for UDP scanning. If we get any UDP response, we can say for sure that the port is open. If we don't get any response, the port might be open or filtered by the firewall. And if we get an ICMP port unreachable, we can say that the port is closed. We might get ICMP from the firewall as well, but that is really rare. Firewalls just usually drop the packets silently. If we have determined which ports are open, we also want to find out which services are listening on the target machine. And that is what the -sv switch is used for. So let's run a scan with version detection. This provides us a lot of information. For example, we have found out that the target is running Apache web server with version 2.4.59. We can easily find out if that is true. And that's right. Nmap correctly detected the version of the web server. But besides that, we can also detect the operating system of the target host with the -o switch, and with the -v we increase the verbosity of the output. As you can see, this is only a guess. So Nmap sends various probes, and based on the response of the target, it tries to determine the OS of the target. But this is much more complex than just detecting SYNAX. It takes into account the starting TTL value, the TCP window size, sequence numbers, and many other things. For example, just to mention the most obvious one, Linux systems usually have a starting TTL of 64. So if I ping the target, which is a Linux system, it responds with a TTL of 64. And if I ping my Windows system, it has a TTL of 128. But besides that, there are several other factors, and keep in mind that this is only a guess. So nmap says that the target is a Linux system, which is true, and with the probability of 91%, it has a kernel version of 2.6.32, which is unfortunately not true in this case. So take it with a grain of salt.